Good morning, sir. My name is Anju and roll number 242123 from IIT Guwahati. Today I am presenting my project titled Netflix Shading, Netflix Content Intelligence and Recommendation System. This project performs end-to-end data analysis on Netflix metadata using NLP, machine learning, clustering, hypothesis, testing, and finally building a content-based recommendation system. Let's focus on the problem statement. Now, what is the problem statement here? Yes. Now, the Netflix dataset is really large, unstructured, also multidimensional. We have many issues here. First is information overload. There are too many titles. It is very difficult for user to choose which title I should choose. And also there is unstructured metadata. Cost, genres, description, character are really messy and they all are multi-valued. Third thing is there is no labeled categories. So we really require here unsupervised learning. Second thing is there is no user history data. So we must build a content-based recommender. So the whole core problem here is how can we convert raw Netflix metadata into a structured features, analysis patterns, and build a recommendation engine. So that is our core problem. Next, next slide, we move to the data set description. Now, what is the description of data here? Is so my data is a 12 column metadata file from Kaggle, which is taken from Kaggle, contains around 8,807 titles, including both movies and TV shows. The data set attributes are show ID, type, in which there are two types, that is movie or TV show. One of the is title, director, cast, country, which countries are producing those movies, date added, release year, rating, duration listed in description. So this data set is suitable for exploratory data analysis, text mining, also principal component analysis, clustering, hypothesis testing, and recommendation modeling. So this is the description of data set. Now we will talk about here, I'm going to talk about here is architecture overview. Here, my data set input has 12 attributes, which I have described earlier. Now, I have uh, there are six major components in this architecture. First is data pre-processing. Second is text processing, in which I'm going to use NLP pipeline. Third is feature extraction, is in which I'm going to apply some TF, IDF, and also PCA. Fourth thing is clustering, clustering, in which I'm going to use a machine learning model using K-means model. I'm going to cluster the things, the movies and TV shows. Third, I will generate a graphical view of the data to see the hidden part of data, and then we are going to validate it with the use of statistical hypothesis testing. Then we are going to see the recommendation system using cosine similarity. So this pipeline converts our raw text into a meaningful insights and recommendations. So first we will talk about data pre-processing. Now what I did here in pre-processing, that in this step I clean the data set, like filled missing values in director column, cast column, and country column. I also standardized duration movies in minutes, shows in seasons. I also converted date added into date time and extracted year, month, day from it. I also removed various duplicates and treated outliers. I excluded multi-valued fields like cast, director, and genres. So this data pre-processing is going to convert messy metadata into a structured analyzable format. Now my data is ready to analyze. Now we are talking about here text processing. Now, what is text processing? Here, cleaning, normalization, stop word removal, tokenization, lemmonization, keyword tagging, creation of content uh, description. So here, I'm going to build, basically, I'm building a complete NLP pipeline. NLP, which natural language processing here. So what I'm doing here is I'm cleaning and normalizing this, removing punctuations, digits, URLs, and and also standardizing this text to lowercase for uniformity. Also, I'm removing stop word removal. Like I'm eliminating frequently occurring words in the text into a meaningful way. I'm also splitting those texts into an individual token for structured NLP processing, which is also known as tokenization. Now, next thing is lemmatization. So I'm going to convert the words in text to their base forms to reduce vocabulary and improve the model accuracy, so that model could understand what it really want to convey. Third thing I use here is POS tagging, in which it helps us to identify grammatical roles of words to extract contextual and semantic information. To know the semantic information and extracting contextual meaning to the model, so that model could understand that. So then I created a content detail that is going to combine various values like title, director, past, genre, and description into a single rich text field for vectorization. So I'm going to use vectorization here. So finally, created a combined text field which is called content detail. So this is going to serve as the main text input for for TF ideas. Now I'm going to use here feature extraction layer. Now, what feature extractions are doing here is TF idea factorization, and second is PCA dimensionality reduction. So first, TF factorization. It is going to transform cleaned text, which is used in the column title, cast, genre, description, and director. So it is going to transform those clean text into a numerical vectors that is going to represent importance of word across the data set. Now this is helping the model to understand the semantic similarity between these different shows and movies across the data set. Now, second thing is we are using here is PCA. So PCA is going to help us. So we are basically doing what, like reducing thousand of TF IDF dimensions. Like the TF IDFs gives 30,000 plus dimensions. So PCA compresses them into a 200 to 300 components. Now this is going to remove those noise. Also, it is going to improve clustering and reduces computational cost while preserving meaningful patterns. Now, this is going to boost processing speed and enhance clustering here. Now, our data set is ready to, uh, we are ready to to deploy. We are ready to apply a machine learning model to it. So it is ready to apply some machine learning model. So we are using here is unsupervised model, which is k-means, to cluster the data set. So for unsupervised learning, I used k-means clustering. Here, k-means clustering is going to group the Netflix titles into cluster based on similarity of content features, like PF idea vectors is reduces using PCA. Now is it going to produce theme-based clusters such as horror, documentary, teen dramas, stand-up comedy, kids, etc. So this cluster represents hidden content themes like uh, what I have mentioned right now. Now, for k means we need to decide the value of k. How can we decide the value of k? So I will use elbow method for that. So elbow method are going to I'm going to use elbow method, which is used to find optimal number of clusters. So I'm going to plot the graph between a number of clusters and plotting WCSS. So WCSS is nothing but a within cluster sum of squares. So it is going now after plotting a graph between the K clusters and WCSS, I will find the suitable elbow point where adding more cluster provide minimal improvement. So I will take that down. So that is going to be my true value. Now it is going to It is going to ensure that this helps discover meaningful structure in Netflix data. Now we will do exploratory data analysis. Now there are like I have a movies versus TV, country-wise spread, genre distribution, trends over years. So I'm going to made a graph of both these things, and then I'm going to validate using hypothesis testing. So here I have analysis the proportion of movies and TV shows which is available on Netflix. I also identifies which countries is contributing the most titles and how content is globally distributed. Also examining the most common genre to reveal audience preference and platform trends, and also observe how Netflix content library has grown annually, which years saw major additions. Now I'm going to apply here is to validate these results, I'm going to use hypothesis test. So I apply here, I perform hypothesis testing here. So what hypothesis testing is doing is it is going to validate those EDA which I have analyzed earlier. Now, first I want to know that what was the average duration in 2020, and what was the average duration of TV in 2021. So now I'm going to apply here t-test. So it is going to compare two different group. It will check their means and in a scientific way, and also we will get some p-value from here. If it is greater than 0.005, then there is no significant difference. This means that although this means that the duration may look different on graph, but what happened is mathematically they are not really different. So TV show durations did not change significantly between 2020 and 2021. Now, the second thing is we have also applied here on rating. Since rating has categorical columns, so we are going to use here, we are going to use the test here. So I want to know that does India have more TV 14 rated content, or does the US have more TV MA content? So because rating are categorical, we are going to apply z-test. So I got p-value less than 0.005, which is significant difference. It means that countries do have different type of ratings. So rating distribution are varying across countries. Third thing is year-wise content. So we are seeing that in graphs that content added on Netflix spikes around 17 to 2020. But to be sure, we need to perform another test here. So yes, we saw statistically that yearly addition are statistically different. This means that the rise in Netflix content over the year was real. It was not a random. So now we have applied. Now the recommendation system results. So this slide is about that the final part of my project is nothing but a content-based recommendation system. So first is TF, IDF, and cosine similarity. So TF, IDF to represent the semantic of each title, and cosine similarity is going to find the closest titles. For example, if there is a user who has put quota factory as an input, then output will show like ye hai meri family or engineering girls Chaman Bahar. These content is going to show to user. Now these matches because they share similar themes, language patterns, and also context. So the result is here. So this was the Indian title, like Input Quota Factory. It is going to recommend show Ye Hai Meri Family Girls Hostel because they share youth-centric narrative, college, school life. So the outcome is it is going to deliver personalized, theme-aware recommendation that user want to know. Now the conclusion is that the achievement here is I successfully built an natural language processing, principal component analysis, and clustering pipeline. It extracted hidden content themes from Netflix dataset, and the statistical test confirmed dataset patterns. Also, this recommendation system are producing accurate and meaningful suggestion. So the overall system works end to end. Now the conclusion is to conclude. I want to say that I transformed raw Netflix metadata into a structured ML features. I applied advanced natural language processing, TF-IDF, PCA, and clustering. I validated insights with statistical testing. I built a working content based recommendation model. So this project shows how data mining, NLP, ML can be combined to analysis certain OTT platforms. So I have future works, like in future I plan to use BERT sentence using deep learning embedding hybrid recommendation system, advanced clustering techniques, incorporating sentiment or review data. So that's all. Thank you.